We didn't discover 3-eye atlas because we were brilliant. We discovered it because it allowed us to. So if 3-eye atlas wasn't a passive object, but a test, what level did humanity just fail? The data from 3-eye atlas was real. It came from multiple observatories across different instruments, using independent methods. Its trajectory, speed, and origin were not disputed. This was not a case of bad measurements or faulty detection. And yet, something unusual happened. No decisive conclusion followed. No definitive explanation emerged. There was no bold announcement. No confident declaration. No final answer presented to the public. This silence was not caused by a lack of information. It was caused by the opposite. Too much data pointing in different directions. Enough evidence to rule out simple explanations, but not enough to confirm a single truth. Modern science is built to speak with confidence. It excels at narrowing uncertainty, not living inside it. But with 3-eye atlas, every explanation came with an asterisk. Every model worked partially and failed quietly at the edges. So science did what it rarely does in public. It paused. It waited. It chose restraint over speculation. In that moment, silence became the safest response, not because scientists had nothing to say, but because saying too much would have meant pretending to know more than they did. And that raises an uncomfortable question. When science goes quiet like this, is it showing weakness? Or is this the most honest moment science can have? We never encountered 3-eye atlas directly. We watched it from a distance, through instruments that translate reality into light. Numbers and probabilities. There was no approach, no interception, no chance to alter its path or slow it down. By the time we confirmed what it was already moving away. The observation window was brief, and it will never repeat. Unlike objects bound to our solar system, 3-eye atlas does not return on a predictable schedule. There is no second pass, no opportunity to refine measurements, no chance to correct early assumptions. What we captured is all we will ever have. Even our most advanced tools remain constrained by fundamental limits. Distance weakens signals. Motion blurs detail. Light itself carries only partial information. Every measurement arrives filtered, delayed, and incomplete. We are not touching reality. We are reconstructing it from fragments. That means our understanding of 3-eye atlas was never direct. It was inferred, built from spectra, brightness curves, and motion traced across the sky. Useful, precise, and scientific, but still indirect. What we know is not the object itself, but the shadow it casts on our instruments, and that may be the most uncomfortable part. If everything we know comes second-hand, translated through layers of limitation, then the question is not just how much we know, it is whether we are truly understanding what we see or simply learning how to guess more carefully. Modern astronomy often gives the impression of control, bigger telescopes, sharper images, larger datasets. From the outside, it can feel as if the universe is slowly being mapped, categorized, and brought under human understanding. But scale does not equal mastery. A more powerful instrument only expands what we can see, not how much we truly comprehend. More data does not automatically lead to deeper insight. In many cases, it increases complexity. Models grow more detailed, simulations more precise, but they remain anchored to familiar conditions. Physical laws are tested, refined, and trusted within regions we have studied repeatedly. Inside those boundaries, predictions work remarkably well. Interstellar objects like 3I Atlas exist outside that comfort zone. They arrive from environments we cannot observe directly, carrying histories shaped by conditions unlike anything in our solar system. When such an object appears, our models do not fail dramatically. They work partially, enough to explain fragments, not enough to form a complete picture. 3I Atlas did not violate known physics. It did something more subtle. It behaved in ways that did not fully align with our expectations, not because the laws were broken, but because the framework we used to apply them was built for a different neighborhood of the universe. The illusion, then, is not that science is wrong. It is that control was ever complete. Our theories are powerful, but they are local. Our confidence is earned, but it is conditional, and when something arrives from far beyond those conditions, the limits quietly reveal themselves. So the question becomes less about what 3I Atlas is doing wrong, and more about what our assumptions might be doing to us. If the universe does not operate according to the models we rely on, then where does the problem truly lie? Not everything in the universe is oriented toward us. Much of what exists does so without reference to human observers, human timelines, or human curiosity. We often assume that if something can be seen, it must also be meant to be understood. But that assumption says more about us than about the cosmos. It is possible that 3I Atlas did not emit clear signals simply because it had no reason to. No need to announce itself. No requirement to perform in ways that align with our expectations. What we detected may not have been communication at all, but incidental evidence, the unavoidable byproduct of motion. Chemistry and physics interacting with our instruments. From that perspective, observation becomes accidental. We noticed 3I Atlas not because it revealed itself, but because our line of sight briefly intersected its path. There was no message to decode, no pattern to interpret, no sign designed for recognition, only a short presence, followed by absence. In that sense, its passage resembles something far more ordinary, an object moving through a system that barely registers the observers within it, like something passing through a field of insects, not altering its course, not acknowledging what it passes by, and leaving no trace once it is gone. If that is the case, then The discomfort we feel is understandable. We are accustomed to being part of the story. We expect meaning to point back toward us. But if we were never the intended audience, then perhaps the problem is not that answers are missing. Perhaps the deeper question is whether we were ever entitled to them in the first place. The idea is speculative, but it follows a quiet logic. 3I Atlas appeared, passed through our region of space, and departed once. It did not slow down. It did not adjust its trajectory to remain observable. It did not behave as if discovery was the goal. Everything about its motion suggested continuity, not reaction. From that perspective, its path looks less like a random encounter and more like a predefined route. A trajectory set long before it entered our solar system, followed without deviation. It moved through different environments, crossed regions of varying radiation, magnetic fields, and solar influence, and then continued on, unchanged by our presence. If such a passage were meant to gather information, communication would not be necessary. Data does not require dialogue. It requires exposure. A simple transit through space can sample conditions, record interactions, and register change without leaving anything behind. No signal needs to be sent outward. No trace needs to remain once the route is complete. Seen this way, observation becomes asymmetric. We watch it pass, believing we are the ones collecting knowledge, while the object itself remains indifferent. Nothing about its behavior suggests acknowledgement. Nothing suggests response. It arrives, moves through, and exits cleanly. That is what makes the idea unsettling. A pickup mission would not announce itself. It would not wait. And it would leave no evidence that anything had been taken at all. If something like that were happening, then the question shifts quietly but fundamentally. In this encounter, were we truly the observers, or were we simply part of the environment being sampled? At this point, skepticism matters. Every hypothesis, especially speculative ones, must pass through restraint before it earns attention. The simplest explanation should always be considered first. Unusual behavior does not automatically imply intention. Rarity alone is not evidence of design. The universe is vast, and scale itself generates strangeness. Extreme environments produce configurations we rarely encounter and do not yet fully understand. Objects formed under unfamiliar conditions can appear anomalous without being artificial. History is filled with examples where the unknown eventually became natural once understanding caught up. There is also a human tendency that cannot be ignored. When we encounter something we cannot easily explain, we project agency onto it. We assign purpose, direction, and meaning where uncertainty exists. This impulse is deeply rooted, and it often says more about human psychology than about the phenomenon itself. Skepticism exists to counter that instinct. It slows conclusions, filters bias, and protects science from turning curiosity into belief. Without it, speculation becomes storytelling. With it, speculation becomes disciplined inquiry. But skepticism has its own limits. When it hardens into dismissal, it can quietly narrow the range of questions we allow ourselves to ask. Rejecting every unfamiliar possibility is not the same as thinking critically. So the balance matters. Skepticism should keep us grounded, not blind. And that leads to a more subtle question. Is skepticism helping us remain clear-headed, or is it quietly defining the boundaries of what we are willing to imagine? Some of the observations from 3I Atlas did not sit comfortably alongside what we expect from typical comets. Certain behaviors could be explained, but only partially. Other signals resisted clean interpretation altogether. Nothing was wildly inconsistent, yet nothing aligned perfectly either. As more data accumulated, models had to be adjusted. Parameters were refined. Assumptions revisited. Edge cases expanded. Each update improved one aspect while introducing new uncertainties elsewhere. No single hypothesis emerged as a clear winner. Instead, multiple explanations coexisted, each accounting for part of the picture, none able to claim completeness. This kind of situation is deeply uncomfortable for linear thinking. We prefer clear chains of cause and effect, tidy conclusions, and decisive outcomes. Science is often presented that way, even when the process itself is far messier. But with 3I Atlas, the mess could not be hidden. Science does not fail when models struggle. It adapts, but adaptation requires tolerance for ambiguity. And that is something we are less practiced at accepting. We want data to behave, to settle into familiar frameworks, to confirm what we already understand. The problem is that the universe has no obligation to cooperate. Ambiguity is not an error state in nature. It is often the default. When data refuses to fit neatly, it forces a choice not between right and wrong answers, but between how tightly we cling to our models and how willing we are to let them change. So when the data refuses to behave, the question becomes unavoidable. Do we adjust the data to preserve our thinking, or do we adjust our thinking to follow the data? Human time is brief. Our civilizations rise and fall in spans that barely register on cosmic scales. Even the longest scientific traditions represent only moments when set against the age of the universe. In contrast, an interstellar object like 3I Atlas may carry a history measured in billions of years. Shaped long before Earth formed life capable of observation. What we experienced was not that history. It was a passing instant. A narrow window in which its path happened to intersect with our instruments. Everything we know about it comes from that fleeting overlap. A slice taken from an incomprehensibly long journey. This creates a fundamental limitation. Our understanding is not built from continuity, but from fragments. We reconstruct vast stories from brief encounters. Confident in our methods, yet constrained by perspective. What we call knowledge is often a thin cross-section of a much deeper reality. The universe does not require comprehension to function. It does not slow down for understanding. Nor does it adjust itself to be more accessible. Objects move. Systems evolve. And histories unfold regardless of whether anyone is there to notice. In that context, our position becomes clearer. We are not ancient observers. We are a young civilization, recently equipped with the tools to look outward, still learning how to interpret what we see. The scale gap between us and what we observe is immense. So the question is not simply whether we can explain objects like 3i Atlas. It is whether a civilization at our stage can truly understand something that existed long before it learned how to look up at the sky. Throughout its passage, 3i Atlas did nothing to draw attention to itself. There was no sudden change in behavior. No response to observation. No moment that suggested awareness of being watched. It did not react when instruments turned toward it. Nor did it alter its path in ways that invited closer scrutiny. It did not perform. It did not adapt to human curiosity. It simply moved, indifferent to the fact that it had become an object of intense study. This absence of reaction is easy to overlook. Yet, it may be one of the most telling aspects of the encounter. We often assume that signals must be active, something sent, broadcast, or deliberately expressed. But in many natural systems, silence is not a gap. It is a state, a default condition. Noise is the exception, not the rule. From that perspective, the lack of response from 3i Atlas does not necessarily mean nothing was happening. Silence requires no effort. It does not conceal, and it does not reveal. It simply exists. There was no attempt to hide, but also no attempt to engage. No indication that recognition mattered in either direction. If silence itself can carry meaning, then interpreting it demands a different kind of attention. Not the search for messages or patterns, but the patience to notice what remains unchanged, what refuses to react, what persists without acknowledgement. And that leads to a quieter question. If silence was the signal, do we possess the subtlety required to recognize it at all? Humans are accustomed to being at the center of their own stories. We interpret events through a human lens, assigning relevance, intention, and meaning in relation to ourselves. Even in science, discovery is often framed as something that happened for us, or because of us. This perspective makes it difficult to accept indifference. We are far more comfortable with threat, communication, or mystery than with irrelevance. Being misunderstood can feel unsettling, but being unimportant is often harder to process. 3i Atlas did not ask to be noticed. It did not arrive on a schedule we chose, and it did not conform to narratives that place humanity in a meaningful role. It appeared, passed through, and departed without offering closure or reassurance. There was no satisfying answer at the end of the encounter. No confirmation of danger. No promise of connection. No clear lesson delivered in a form we prefer. Its presence did not adapt to our emotional expectations, and its absence did not resolve them. What remains is discomfort rooted not in fear, but in perspective. The realization that some phenomena do not revolve around us, do not respond to us, and do not care whether we understand them or not. And that leads to a question that is less scientific and more personal. What unsettles us more, not knowing what something is, or realizing that it may not matter to us at all? If there is one thing encounters like 3-eye atlas make clear, it is that the next interstellar object will not arrive on our terms. It will likely be detected later than we would hope, already deep into its passage by the time certainty replaces suspicion. The discovery will feel sudden, even though the object itself has been traveling for millions or billions of years. It will pass quickly. There will be little time to observe, limited opportunities to adjust instruments, and no chance to plan a response in advance. As before, it will trigger debate. Familiar questions will resurface. Is it natural? Is it unusual? Are we missing something again? The discussion will echo what we have already experienced. Despite advances in technology, direct interaction will remain out of reach. Distance, speed, and energy constraints will still dominate the encounter. We may be better prepared than before, but preparation does not equal control. Observation will still be passive, reactive, and constrained by physics we cannot bypass. What will change? Incrementally is refinement, faster identification, slightly better coordination, marginally clearer data. Each encounter will sharpen our tools, but only at the edges. Progress will be real, yet modest. And that is the pattern to watch. Not dramatic breakthroughs, but small adjustments layered over time. The question is whether those adjustments add up to understanding, or simply to familiarity. So as we look ahead to the next interstellar visitor, the issue is not whether we will learn something new. It is whether we are moving forward quickly enough or quietly repeating the same lesson, one passing object at a time. Consider a different possibility. What if no direct contact was ever required, no signals to decode, no response to provoke, no interaction to confirm? What if observation alone was sufficient, not of the object itself, but of how a civilization reacts when confronted with uncertainty? From that angle, Atlas does not need to do anything at all. It simply appears, follows its path, and leaves. The real activity happens on our side. Speculation accelerates. Arguments form. Fear mixes with fascination. Every gap in understanding is filled with assumption. Science. Meanwhile, attempts restraint. It moves carefully. Emphasizes uncertainty. And avoids premature conclusions. But outside that discipline, interpretation spreads quickly. Headlines simplify. Narratives harden. What began as data becomes belief. Then controversy. In this scenario, the object remains passive while the observers reveal themselves. The focus shifts away from what 3-eye atlas might be, and toward how we handle not knowing. Our reactions emotional, social, and institutional become the measurable output. If that were the case, then the most meaningful information was never carried by the object at all. It was generated by us, by how we argued, how we speculated, how we communicated uncertainty, and how comfortable we were with silence. And if this encounter functioned as a kind of test, not of technology, but of maturity, then the question is unavoidable. Based on how we responded, what score would our civilization actually receive? In the end, the most honest scientific answer is also the least satisfying one. We do not know. Not yet. And pretending otherwise would undermine the very process that allows science to function at all. There was no attempt to force certainty where it did not exist. No rush to frame incomplete understanding as a finished conclusion. Instead, restraint prevailed. Limits were acknowledged. Assumptions were marked clearly. What could be said was said carefully. And what could not be confirmed was left open. This approach is not weakness. It is discipline. Science does not advance by declaring answers prematurely, but by preserving uncertainty until evidence earns resolution. With 3i Atlas, the responsible choice was to record, archive, and wait, to treat the data not as a headline, but as a reference for future encounters and better tools. There is value in admitting boundaries. It keeps inquiry alive. It allows understanding to grow without collapsing under the weight of false confidence. In this case, honesty mattered more than spectacle. Accuracy mattered more than reassurance. But honesty has a cost. It offers no closure. It does not satisfy curiosity or quiet speculation. It simply states the limits of what is known at this moment in time. And that raises a difficult question. Not for science, but for society. Are we ready to accept an answer that does not resolve the mystery, or do we demand certainty, even when none can be responsibly given? What 3i Atlas left behind was not a threat. It did not deliver a warning. Nor did it reveal evidence of anything extraordinary that could be held up as proof. There was no final revelation. No clear takeaway that neatly resolved the questions it raised. Instead, it left a gap, a space where certainty should have been, but was not. A question mark suspended between what we observed and what we could confidently explain. That absence may feel unsatisfying, but it is also revealing. The encounter forced a moment of humility. It reminded us that discovery does not always come with understanding, and that contact does not guarantee clarity. Sometimes the most honest outcome of observation is recognizing how much remains out of reach. That realization carries value. A gap in knowledge is not a failure, it is a direction. It highlights where preparation must improve, where detection must be faster, where coordination must be stronger, and where patience must replace urgency. Each unanswered question sharpens the need to be ready for the next encounter, rather than confident about the last one. What 3i Atlas ultimately left behind was not information we could finish interpreting, but perspective. A reminder that progress often begins with acknowledging what we do not yet grasp. And now the responsibility shifts to us. Faced with that open space, will we use it as motivation to learn and prepare, Or will we rush to fill it with speculation simply to escape the discomfort of not knowing? 3. Atlas did not need us. It did not arrive for our benefit, did not alter its course for our curiosity, and did not leave answers behind to comfort us. It passed through, unchanged by our attention, and continued on its way. But we needed it, not as proof of anything extraordinary, and not as a source of certainty. We needed it as a mirror, something that forces us to look at our assumptions, our confidence, and the quiet limits beneath both. Science did not fail in this encounter. It reached a boundary, a moment where observation outpaced explanation, where honesty mattered more than resolution. That is not weakness. It is the edge where understanding begins, not where it ends. To be small in a vast universe is not a flaw. It is a condition. Humility does not diminish knowledge, it protects it. It keeps inquiry open, curiosity alive, and progress grounded in truth rather than comfort. The universe will continue regardless of our conclusions. Objects will pass. Histories will unfold. Patterns will exist whether or not we recognize them. Our role is not to demand answers on our timeline, but to remain attentive when they are not yet ready to appear. So if the universe does not wait for us to understand it, then the real question is not about what it owes us. It is about what we owe the process of listening. Are we willing to keep listening, even when the answers remain silent?